When dealing with an older IT circuit breaker that has a temperature rating of 40 degrees Celsius, the standard ampacity tables found in the National Electrical Code, such as Table 310.16, cannot be directly used to determine the appropriate conductor size. These tables provide ampacities for conductors based on temperature ratings of 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The crucial factor here is the circuit breaker's temperature rating. The circuit breaker's terminals are only designed to handle conductors operating at or below 40 degrees Celsius. If you use the ampacity from the 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius columns in Table 310.16, you risk overheating the terminals of the circuit breaker, potentially leading to insulation degradation, premature failure of the breaker, and even a fire hazard. The only reliable method for sizing conductors connected to a 40 degrees Celsius rated circuit breaker is to consult the manufacturer's data for that specific circuit breaker model. This data should provide the allowable ampacity for conductors connected to the breaker's terminals, considering its 40 degrees Celsius temperature limitation. Look for documentation, specification sheets, or installation instructions provided by the manufacturer, in this case, IT, if available. These documents will specify the conductor size and type that are approved for use with that specific breaker while remaining within its temperature rating. If the manufacturer's data is unavailable, which can be the case with older equipment, it's essential to exercise extreme caution and consider consulting with a qualified electrical engineer or a certified testing laboratory. They may be able to perform calculations or tests to determine the appropriate conductor size for the given application, ensuring that the temperature limitations of the circuit breaker are respected. In the absence of specific manufacturer's data and without expert consultation, it is generally recommended to replace the 40 degrees Celsius rated circuit breaker with a modern breaker that is rated for at least 75 degrees Celsius. This allows you to utilize the ampacity values from Table 310.16, making the selection process more straightforward and reliable. Furthermore, it is essential to consider the specific application and load requirements. In this case, the circuit breaker is feeding an air conditioning unit with a nameplate maximum overcurrent protection requirement of 150 amps. This means that the conductors must be sized to carry at least 150 amps continuously. However, due to the 40 degrees Celsius limitation, simply selecting conductors with an ampacity of 150 amps from Table 310.16 is not acceptable. The conductor size must be selected based on the manufacturer's data for the specific 40 degrees Celsius circuit breaker, ensuring that it can safely carry the 150 amps load without exceeding the breaker's temperature rating. Remember that ambient temperature and other environmental factors can also affect conductor ampacity. If the conductors are installed in an area with high ambient temperature, it may be necessary to further direct the conductor ampacity to account for the increased heat. Directing factors can be found in Table 310.15b2 of the National Electrical Code. Similarly, if multiple conductors are bundled together, it may be necessary to apply adjustment factors as specified in Table 310.15 of the National Electrical Code. In summary, when sizing conductors for a 40 degrees Celsius rated circuit breaker, follow these steps. Firstly, obtain the manufacturer's data for the specific circuit breaker model. This data should provide the allowable ampacity for conductors connected to the breaker's terminals. Secondly, if manufacturer's data is unavailable, consult with a qualified electrical engineer or a certified testing laboratory. Thirdly, consider replacing the 40 degrees Celsius rated circuit breaker with a modern breaker that is rated for at least 75 degrees Celsius. Fourthly, ensure that the conductor size is adequate to carry the load current of 150 amps for the air conditioning unit. Fifthly, apply directing factors and adjustment factors as necessary to account for ambient temperature and conductor bundling. Always prioritize safety and adhere to the National Electrical Code and other relevant electrical codes and standards. It is crucial to consult with a qualified electrician or electrical engineer if you have any doubts or questions about conductor sizing or electrical safety. When dealing with electrical systems, it is important to prioritize safety and adhere to all applicable codes and standards. Improper conductor sizing can lead to overheating, insulation damage, equipment failure, and even fire hazards. Therefore, it is essential to take the necessary steps to ensure that conductors are properly sized and installed. In addition to the steps outlined above, it is also important to consider the voltage drop in the conductors. Voltage drop occurs when the voltage at the load end of the conductor is less than the voltage at the source end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 5% for feeders and branch circuits. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant, which is 12.9 ohms circular mils per foot for copper conductors and 21.2 ohms circular mils per foot for aluminum conductors. I is the current in amps, D is the one-way distance in feet from the source to the load, and Cm is the circular mils area of the conductor. After calculating the voltage drop, compare it to the allowable voltage drop limit of 5%. If the calculated voltage drop exceeds the limit, you will need to increase the conductor size to reduce the voltage drop. In addition to voltage drop, it is also important to consider the insulation type of the conductors. Different insulation types have different temperature ratings and ampacity values. The insulation type must be suitable for the application and the environment in which the conductors will be installed. For example, conductors installed in a hot environment will require a higher temperature rated insulation than conductors installed in a cool environment. The National Electrical Code provides tables listing the ampacity of conductors with different insulation types. These tables can be found in Article 310 of the National Electrical Code. When selecting conductors, it is important to choose conductors that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories. Listed and labeled conductors have been tested and certified to meet safety standards. Using listed and labeled conductors helps to ensure that the electrical system is safe and reliable. Finally, it is important to follow proper installation practices when installing conductors. Conductors should be properly supported and protected from physical damage. Conductors should also be terminated properly to ensure a good electrical connection. Improperly installed conductors can create a fire hazard. In conclusion, sizing conductors for a 40°C rated circuit breaker requires careful consideration of the manufacturer's data, load requirements, ambient temperature, conductor bundling, voltage drop, insulation type, and installation practices. It is essential to consult with a qualified electrician or electrical engineer if you have any doubts or questions about conductor sizing or electrical safety. Remember that safety should always be the top priority when working with electrical systems. Failure to properly size conductors can have serious consequences. Always double-check your work and ensure that all electrical connections are secure. Never work on live electrical circuits unless you are properly trained and equipped. Electrical work can be dangerous, so it is important to take the necessary precautions to protect yourself from injury. When in doubt, always consult with a qualified electrician or electrical engineer. They can provide you with the guidance and expertise you need to ensure that your electrical system is safe and reliable.